Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from part D of refraction of light, that is critical angle and total integral reflection. Before watching this video, my suggestion is watch the concept video first. First understand the concept, okay, and then if you come to this video, then you will understand most of the things, or else many things will be completely new to you. You will not understand it perfectly. All these links, and not only from this chapter, from all the chapter, from all the parts, will be available in the description box. So watch, learn everything and be perfect in physics. So before watching this video, watch the concept video, then you'll understand everything. Without wasting any time, we'll start with our first question. Our first question, how is the critical angle related to refractive index of a medium? This is what we have learnt in concept video. Very simple. They are asking for how that is related. You can write the answer in two ways. I'll teach you both. Listen. First thing, sin C is equal to 1 by mu. Okay, so this is C is nothing but critical angle, mu is nothing but refractive index. That is the question. Critical angle, how critical angle is related to refractive index. See these two, you can write this formula in the exam, or else you can write it as critical angle, okay, is inversely proportional to mu. Inversely proportional. How we can write? Critical angle is inversely proportional to mu. This, like this, you should not write it in the exam. You have to write it in the form of sentence. Critical angle is inversely proportional to refractive index, or else you can write it as, if refractive index increases, critical angle decreases. If the refractive index increases, critical angle decreases. I have taught you three ways. You can write any one in the board exam. You will get complete marks. Our next question, state the approximate value of the critical angle for glass air surface and water air surface. Okay, listen. First, to find the critical angle, we need to know what. In the previous question, we understood that critical angle completely depends upon refractive index for a white light. For different color light, critical angle is different. Keep this in mind. Okay, this is what we have learned in concept video. For white light, whenever we are just generalizing, when we are learning the generalized concept, always we are learning about white light. For different color, it is different. So what we have learned, for to find the critical angle, what we required? Refractive index, correct? Refractive index of the medium. First one, they are talking about glass air surface. Glass air surface. Second one, okay, second one we'll talk about it later. First, glass air surface, we need to know the refractive index. What is the refractive index of glass? Refractive index of glass, okay, is, see, don't worry about this, you just write refractive index, that is 3 by 2. 3 by 2. But what is the formula? To find the critical angle, sin C is equal to 1 by mu. So sin C, or else C, okay, C is equal to sin inverse of, so it is like the refractive index is in the denominator, 1 by 3 by 2, 1 by 3 by 2. The refractive index value is 3 by 2, so it becomes 2 by 3. 2 by 3. See, I know you have only sine 30 degree, sine 45 degree, all those things, but you don't have sine inverse. Very simple. What is the value of 2 by 3? You take that value. Okay, 2 by 3 is nothing but 66, 0.66, correct? 0.66. You will get the log book. If normally they are not going to give these kind of questions. If they give also, they'll give you the standard values like sine 30, sine 45, sine 60, sine 75, all those things they'll give you. But here it is not a standard value. If in this case, these kind of cases, they'll give you the log book. So you can easily find, when you go to sine page, 0.66, what is the angle? Okay, that you are going to write. For sine inverse of 0.66 or 2 by 3, it is critical angle will be 42 degree. This is how we are going to find. Calculation will be very difficult, so they will definitely give you logbook. If they are not giving logbook, okay, they will give you the standard values. First one is done. Second one, it is about water air surface. Water air surface. See, glass air surface means refractive index of glass. Water air surface means refractive index of water. So refractive index of water is equal to 4 by 3. Refractive index of water is 4 by 3. So how we can find this one critical angle? The formula is sin C is equal to 1 by mu. Correct. So see, to find C, sin inverse of 1 by mu is nothing but 1 by 4 by 3. Correct. But 1 by 4 by 3 we can write it as 3 by 4. 3 by 4. These are the very simple mathematics. This you should know. Okay. So then critical angle of 3 by 4, that is nothing but sin inverse of 0.75. In the logbook, wherever you find, in the sign page, wherever you find 0.75, corresponding angle will be the angle we are looking for. That will be 49 degree. That's it. This is how you find the approximate value of critical angle. Our next question, a ray of light incident from denser medium on a boundary separating it from a rarer medium at an angle of incidence equal to critical angle. What will be the angle of refraction for the ray? Very simple question. This is the conditions for critical angle. This is what we have learned in concept video. If the angle of incidence, see, assume this is the normal. Now, what they are saying, the light ray is coming from a denser medium. Okay, they assume this is water and this is air. Water and this is air. From denser medium to rarer medium. If the angle of, see, this is not the angle of incidence. Keep this in mind. Many questions you are going to confuse with whether this is angle of incidence or this is angle of incidence. Most of the time, to confuse you, they will give you this angle. If you take this as an incident ray, complete question will be wrong. What is the definition of incident angle? The angle between the incident ray and the normal. Okay, that is incidented angle. Now, angle of incidence is equal to critical angle of this medium. If these two are equal, the refracted ray will be on the surface. Refracted ray will be on the surface of the medium. Now, if this is the condition, what they are asking, what is the angle of refraction? How we can find angle of refraction? The angle between the normal and the refracted ray. This is the refracted ray and this is the normal. What is the angle? 90 degree. So instead of doing all this, this is the concept. Okay, this you should know. This is what we have learned in concept video. Just for your sake, I am explaining it here. So directly you can write without doing all these things. Just answer is 90 degree. Keep this in mind. If the angle of incidence is equal to critical angle, then the refracted ray will pass on the surface. We are going to solve all the ray diagrams. Okay, diagram related problems in this theory question. Then you will understand it properly. Our next question, the critical angle for glass air surface is 45 degree. Okay, the critical angle, for glass, air surface is 45 degree. This is what we should know. Okay, that means if the angle of incidence is equal to critical angle, it will pass on the surface. Okay, now it is for, they have given it for yellow color. This is for yellow color. Now state whether will be less than or equal to or more than 45 degree for red color and blue color. So we need to find, that is simple, we need to find the critical angle of red color and blue color. Okay, critical angle for red we need to find, as well as second question we'll worry about it later. First, to find, see, whenever they are talking about color, okay, critical angle and total, we are going to learn total internal reflection also, right? Concept video we have learned it. Here we are going to solve few questions related to total internal reflection, critical angle as well as refraction in the same question. So for these kind of question, to find critical angle or total internal reflection, whatever it is, first you need to know the positions of color. Okay, whenever it is getting dispersed, this is the format. Correct. Vibgyr, Vibgyor. This is the order. Correct. Red as maximum wavelength. We know that, right? Red as maximum wavelength. And see, for every question you have to analyze like this only, or else you will get confused, because this question is like a binary question. Binary means more than or less. Correct. It will be more or less. The only two options. Those are called binary questions. Sometimes even though you know the concept, you will write answer wrong. Okay, that's why this is the suggestion. So in the exam, your answers are very simple. Okay, you have to write the answer in a very simple way. Whether they are asking for a critical angle for red, more than that, that's it. More than this or less than that, that's it. You have to, you are going to write. You should not write the complete story, and all those complete story does not carry any mark. So the extra time, answers are very simple. So why they have to give 2 hours for paper, just to make you think properly. So think properly. Okay, Vibgyr, red as maximum wavelength. Okay, violet as minimum wavelength. While this one, wavelength and critical angle are directly proportional. Keep this in mind. They are directly proportional. So for red color, wavelength is more, so critical angle will also be more, maximum. Okay, for violet color, wavelength is less, that's why critical angle is also minimum. So which color we are talking about? Yellow. Yellow is here. For yellow it is 45 degree. Critical angle is 45 degree. For red it is more than 45. Are they asking what is the angle, what is the exact angle? No, whether it will be more, less or equal to. For different colors we know wavelength will be different and critical angle will be different. Only in vacuum the speeds of all the color will be same. Keep this in mind. Only in vacuum the speeds of all the color will be same, but whenever we are not talking about vacuum, speed obviously will be different for different colors. Speed depends upon wavelength. Here we are only talking about critical angle. So critical angle completely depends upon wavelength. More the wavelength, more will be the critical angle. For red color, more than 45, more than 45 degree or more than yellow. Okay, critical angle is for red is more than yellow. Why? Because red has more wavelength compared to yellow. Then we are talking about one more color, which is that blue light. Okay, critical angle for blue. Okay, which it has to be compared with yellow. Yellow is here, blue is here. So if this is 45, this will be less than 45. So for blue it is less than 45 degree. That's it. Our next question, which color of light has higher critical angle, whether it is red or green? We know red has maximum wavelength. More the wavelength, more will be the critical angle. So whenever we compare any color with red, red has the maximum critical angle, because if they ask you reason, you can write because red has maximum wavelength. Okay, and wavelength and critical angle are directly proportional. Okay, this is the reason. If they ask, you should write. If they are not asking, you just have to write red as the more critical angle compared to green for this question. Our next question, fill in the blanks to complete the following sentence. Okay, total internal reflection occurs when a ray of light passes from dash medium to dash medium. See, this is nothing but the condition of total internal reflection. This is what we have learnt in concept video. That is why I always suggest watch the concept video first, then you come back to this video, you will understand everything. So which medium to which medium? What is the condition for total internal reflection? It has to, the light ray has to pass from denser medium to rarer medium. Water to air or glass to air, or you can, when it comes to glass and water, glass is considered as denser compared to water. So from glass to water is also possible, but here they are not looking for an example. They are just asking for what kind of medium. Actually speaking, the answer should be the light ray passes from optically denser medium to optically rarer medium, but without using that word optically. If you write denser to rarer, you will get full mark. Next, we have one more question. Critical angle is the angle of dash in a denser medium for which the angle of dash in rarer medium is dash. So very confusing question, but if you think in a proper way, we will understand this. What do you mean by critical angle? It is the angle of incidence. When the angle of incidence is equal to critical angle, that means critical angle is nothing but the angle of incidence in denser medium for which the angle of what will get? Refraction only. If the angle of incidence is equal to critical angle, what we will get? We'll get refraction only. And okay, in a rarer medium is what will be the angle of refraction? 90 degree. So I'll complete the sentence. Critical angle is the angle of incidence in denser medium for which the angle of refraction in a rarer medium is 90 degree. That's it. Our next question, state whether the following statement is true or false. If the angle of incidence is greater than the critical angle, if the angle of incidence is greater than the critical angle, light is not refracted at all. What do you mean by this statement? See, from the first statement only we will get to know whether it is true or false. If the angle of incidence is greater than critical angle, what happens? It undergoes total internal reflection. This is what we have learnt in concept. Next, when it falls on the surface from a denser medium to rarer medium, this is very important condition. The light ray has to go from denser to rarer. If it is passing from rarer to denser, okay, critical angle, total internal reflection will not come into picture. Keep this in mind. If it is passing from rarer to denser, all these things will not come into picture. Only the ray passes from denser to rarer, then only we have to see about angle, whether angle of incidence is greater or lesser. If it is from rarer to denser, we don't have to think about all these things. It is always refraction. Okay, if it is from denser to rarer, if it is from denser to rarer, if the angle of incidence is greater than the critical angle, it undergoes total internal reflection. That is what he is saying. Instead of saying total internal reflection, he is saying light is not refracted at all, because the light will get reflected. He is talking about light is not refracted. That means this is correct only, right? So answer for this question is true. Our next question, what is meant by the statement the critical angle for diamond is 24 degree? So this is very important question. Here we need to talk about two things always. Okay, I'll teach you how to answer this kind of question. The critical angle for diamond, if it is diamond or any object, don't worry about the object, don't worry about the angle. Okay, what is if the critical angle for diamond is 24 degree? If the critical angle means if the angle of incidence is equal to critical angle, then the refraction will be 90 degree. The refraction will be 90 degree. If the angle of incidence is more than the critical angle, okay, then the no refraction, only total internal reflection within the diamond. This is what you are going to write. So I'll repeat one more time. If the angle of incidence is equal to 24 degree, angle of incidence is equal to 24 degree for diamond, then the refracted ray will be in 90 degree. 90 degree on the surface of the diamond, on the surface of the diamond. So, and if the angle of incidence is more than the critical angle, that is, if the angle of incidence is more than 24 degree, then it undergoes total internal reflection within the diamond. That is why whenever you take diamond, it will not sparkle at all angles. It will not sparkle at all angles. Whenever you keep on rotating at particular angle, it will sparkle. Okay, it will be sparkling. Okay, the shininess, that will be that angle is more than the critical angle, more than the critical angle. If it is more than the critical angle, what happens? Total internal reflection. Whenever light toggles inside a medium, whenever light toggles inside a medium, that is that the toggling is nothing but total internal reflection inside the object only. It will get reflected. Because of that reflection, we will feel it as shininess, and it will sparkle. So it will never sparkle. The light will get reflected inside the object. That is how we get sparkling in diamond. Our next question, name two factors which affect the critical angle for a given pair of media. State how do the factors affect it. Very simple question. This is what we have learnt in concept video. They are asking for two factors when it comes to critical angle. Factors affecting critical angle. The first one is wavelength. Okay, see, you can answer it directly, or you can with knowledge also you can answer. Listen. First, we don't have formula to find critical angle using wavelength. Correct? What is the formula? Sin c is equal to 1 by mu. This is the formula to find critical angle. Okay, but it is not related to wavelength. But see, critical angle is inversely proportional to refractive index. But how refractive index is related to wavelength? Okay, wavelength and inverse this one refractive index are inversely proportional. If refractive index increases, wavelength decreases, all those things, correct? If wavelength and refractive index are inversely proportional and critical angle and refractive index are inversely proportional, see, inversely proportional, assume it as enemy, assume it as enemy. Wavelength and refractive index are enemy. Critical angle and refractive index of enemy. For critical angle, refractive index is enemy. Okay. For refractive index, wavelength is enemy. So critical angle and wavelength both are friends. That means friends means directly proportional. So critical angle, okay, is directly proportional to wavelength. Okay, this is how you can understand. Whenever, see, whenever you are learning a video from YouTube, sometimes you will get doubts. Okay, even though you are learning in a proper way, sometimes you may get doubt which you cannot ask. So what you can do, just reverse, go back and rewatch it again, only this bit you will definitely understand. Okay, wavelength and critical angle are directly proportional, or else you can write it as, see, they are just asking factors, name two factors. Whenever they are asking name, don't write how it is affecting, whether it is directly proportional or inversely proportional, don't write it. They are just asking for naming. Naming means just stating the factors which will affect critical angle. Wavelength is one of the factor which will affect critical angle. What should be your answer? First point, wavelength. That's it. You should not write anything if they are just asking for naming. First point is wavelength. Done. Now there is one more sub question, right? How do the factors affect it? Now you have to write wavelength is directly proportional to critical angle. This is the answer. Full complete marks you will get. Or else you can write it as, if wavelength increases, critical angle also increases. Next, the second point is temperature. Again, there is no direct relation between temperature and critical angle. Again, we have to deal this one with refractive index. If you increase the temperature, okay, refractive index decreases. This is what we have learnt in first part. From the first part, or from the first part, whatever is there, it is all required for till you complete the part D. Okay, so temperature is inversely proportional to refractive index. These two are enemies, correct? The critical angle and refractive index, already they are enemies. This is, okay, temperature is enemy of refractive index, a refractive index is enemy of critical angle. So critical angle is a friend of temperature. That means temperature and critical angle are directly proportional. See, if these two are inversely proportional and these two are inversely proportional, okay, these two will be directly proportional. Understood? So in the middle, what we have? Refractive index, correct? In the middle, see, very simple. How you can understand in like this? Sin C is inversely proportional to refractive index, and refractive index is inversely proportional to temperature. Okay, only this, see these two. Okay, temperature is inversely proportional to refractive index. If you remove this part, sin C will be directly proportional to temperature. That means as the temperature increases, the critical angle also increases. Any one you can write. Temperature and critical angle are directly proportional. So this is how you write the factor. Or else, if the temperature increases, critical angle also increases. For a safer side, okay, many students I know, whenever they get getting these kind of questions, they'll get fear. The directly proportional and inversely proportional words are not in the textbook. So if you use that, you will not get marks in the exam. No, you will definitely get marks in the exam. Okay, so what they'll do, they'll write critical angle and temperature are directly proportional. That is nothing but, if you increase the temperature, critical angle also increases. So both are same. The statements, both which you are writing are same. Instead of writing both of them, write any one. Our next question. The refractive index of air with respect to glass is expressed as, okay, is equal to sin I by sin R. Sin we know, I means angle of incidence, R means angle of refraction. This is the given data. So first sub question, write down the similar expression for mu A G. Okay, if G mu A is sin I by sin R, mu A mu G will be sin r by sin i. Okay, here in this question they have not asked one more question which was asked in 2024, which assume this is the answer. Okay, we got to know the answer, so they'll ask one more question. By what principle this is based on? This is based on principle of reversibility. This is what we have learned in part A. So if see refractive index of one medium, okay, glass to air, assume any value, glass to air is 4 by 3, then air to glass it will be 3 by 4. Okay, you got the idea? If whatever the value they give, okay, here you take the reciprocal of it whenever these two interchanges. Okay, next question B, we'll go for question B. If angle of refraction is 90 degree, when the corresponding angle, okay, what is the corresponding angle of incidence called? See, if the angle refraction is at 90 degree, angle of incidence is called as critical angle. The answer will be critical angle. Next one, third sub question. What is the physical significance of angle I in part B? This is part B. Okay, angle I in part B. See, whenever they are talking about physical significance, that means they are talking about total internal reflection. Keep this in mind. Physical significance of incident ray, okay, is always total internal reflection. Keep this in mind. So to get total internal reflection, what should happen? If the angle of incidence, okay, is greater than the critical angle, okay, it undergoes total internal reflection. This is the physical significance. So whenever they are talking about physical significance related to angle of incidence, this is what you are going to write. If the angle of incidence is greater than the critical angle, it undergoes total internal reflection. Our next question, mention one difference between normal reflection from the plane mirror and total internal reflection from the prism. Very simple. This is what we have learnt in concept video. In concept video I have taught you 4 differences. So here in this question they are just asking for only one. You can write any one. So most of the time it is very easy to remember. In total internal reflection, no loss of energy. Total internal reflection, no loss of energy. In reflection, okay, from a plane mirror there will be a loss of energy, okay, because of absorption of energy. Then here total internal reflection, the image will be brighter. Here the image will be less brighter compared to total internal reflection. Why the image will be brighter? Because there is no loss of energy. So we have learned 4 differences. You can write any one. See, in the board exam, if they are asking any differences between any 2 physical quantities, the maximum marks allotted for those kind of questions will be 1. Okay, in physics exam, if you want to score more than 70, you have to be very good at reasoning. Okay, because if you analyze the paper properly, 30 to 45 marks only for reasoning, in a different way. It may be in MCQs, it may be a sub question of one more question. In this way they are going to ask the questions. So if you analyze it properly, 30 to 45 marks of questions will be there for give reasoning. So you have to be very good at reasoning. Our next question, state one advantage of using total reflecting prism as a reflector in a place of plane mirror. In plane mirror also will get reflection. So why do you have to take prism only? This is what, if you know the differences, you can write the answer. In a plane mirror, there will be a loss of energy, but in total internal reflection, there will be no loss of energy, and the image is also brighter in total internal reflection. Okay. In normal reflection, it will not be that bright compared to total internal reflection. This is the advantage. They are asking for one advantage, you write only one. Don't write extra, and if that extra part is wrong, you will lose marks. So this is the answer for this question. Our next question, explain the term critical angle with the aid of a label diagram. Till now we have understood what is critical angle. They are asking us to write the definition. Very simple. See, critical angle is nothing but the angle of incidence for the corresponding angle of refraction, that is 90 degree, whenever a light ray passes from denser medium to rarer medium. If you miss this word from denser medium to rarer medium, even though the first statement is correct, you will never going to get mark. only few definitions like Ohm's law and this one. Ohm's law, if you write everything and if you miss the temperature and other physical quantities remain constant, if that sentence is not there for whatever you have written in the first part, that will be completely wrong. Only few definitions are like this. Okay, whenever it comes to critical angle, you have to mention the light ray is coming from denser medium to rarer medium. That's it. And they are asking for a diagram. So very simple. This is the normal. So never ever you should write the normal first. First you have to write the incident ray. Okay, this is angle of incidence. If the angle of incidence is equal to critical angle, okay, it will go on the surface. It will go on the surface. This diagram is very easy to understand because surface is this one. Whenever we are talking about prism and all, we need to know which is on the surface and all. That is what I am going to teach you using the diagram which is there in the textbook. Once you learn all these things, try to solve this one diagram problems. Then you will understand, when you will get the complete knowledge about the concept. So this is the angle of refraction and the angle will be 90 degrees. That's it. Our next question: what is total internal reflection? State two conditions necessary for total internal reflection. Draw the diagram. Okay, so this is the question. First we'll go one by one. First one, total. What is total internal reflection? Very simple. See, when a light ray passes from denser medium to rarer medium, see, very important. Okay, for whether critical angle or total internal reflection, the light ray has to pass from denser to rarer. This is what you have to write first. Okay, whenever a light ray passes from denser medium to rarer medium, if the angle of incidence is greater than the critical angle, the complete reflected ray, okay, the ray will get reflected. The ray will get reflected back into the denser medium. This process is called as, or this phenomenon is called as total internal reflection. This is the phenomenon. Next, they are asking for state two conditions. There are two conditions for total internal reflection. Very simple. Though based on those two conditions only we have defined it. Okay, very simple. See, in the exam they are going to ask this one or this one. They will not ask both. Okay, none of the question, okay, will be for 2 marks. Most of the question will be for 1 mark only. If they have 4 mark question, 4 subdivision questions will be there. So, or else for steps. Okay, here they'll ask this question or this question, definition of total internal reflection or condition. You should know everything. Based, okay, using the definition of total internal reflection, how can we answer this condition? Very simple. The light ray has to pass from denser medium to rarer medium. First condition. Next, second one, the angle of incidence should be greater than the critical angle. That's it. These are the two conditions. So they are asking for the diagram also. Okay, again you should not write the normal line first surface. Okay, angle of this is the incident ray. At this point you have to draw the normal. See, when the angle of incidence is greater than the critical angle, okay, when the angle of incidence, when I is greater than critical angle, it undergoes total internal reflection. It goes back to the same denser medium. This is the diagram they are looking for. That's it. Our next question, figure below shows two rays A and B. This is A and this is B, traveling from water to air. So here analyzing the medium is very much important. The ray is coming from water to air. So that means it is passing from denser medium. Water is denser compared to air. So air is rarer medium. This is the important thing, from denser to air. So they have not specified directly water to air. That is nothing but denser to rarer medium. If the critical angle for water air surface is 48 degree, complete the ray diagram showing the refracted ray for each. State two conditions. Okay, that is the second sub question. We'll go for it later. Now here, if the critical angle of water air surface is 48 degree, assume this is the critical angle. Okay, if the angle of incidence, if there are two, you can write it. They are asking for both. See, the ray diagram showing the refracted ray for each. That means one critical angle, whenever they are talking about each, okay, refracted for each, that means one is critical angle, one is total internal reflection. That means whenever I value is equal to C value. When I value is equal to C value, what will get? Refraction. See, this writing part is not required, just for you to understand. Refraction at 90 degree. Okay. So if I is equal to C, the ray will go on the surface and that will be 90 degree. If, okay, here if I is greater than critical angle, it will undergo total internal reflection. It undergoes total internal reflection. This is the diagram they are looking for. Then state conditions when the ray will suffer total internal reflection. This is what we have learned in previous question, correct? What are the conditions for total internal reflection? The light ray has to come from denser medium to rarer medium, first condition. Second condition, the angle of incidence should be greater than the critical angle. These are the two conditions for total internal reflection. Our next question, figure shows a point source P. This is the source P inside a water container. Three rays A, B, C. This is A, this is B, and this is C. Okay, starting from the source P are shown up to the water surface. This is the water surface. First, show in the diagram the path of rays. These rays, after striking water surface, the critical angle for water air surface is 48 degree. That means, see, the angle of incidence, okay, and critical angle of, using the angle of incidence, we have to draw the complete the diagram. One hint they have given, water air surface is 48 degree. Critical angle, okay, is 48 degree. See, most of the time, 90% of the time, they'll give you this data. If they are not given, you need to know critical angle for water is 48 degree. Keep this in mind. Okay, next. So we have to first complete the ray diagram. That is the first question. So you see, this second one is 48 degree. First one, it is clearly, we can easily understand that the angle of incidence is less than 48 degree. Okay. So when the angle of incidence is less than 48 degree, normal refraction, okay, it undergoes normal refraction. But here the important thing is whether it goes away from the normal or towards the normal. We know whenever a light ray from denser to rarer medium, the speed increases. Denser to rarer medium, speed increases. If the speed increases, it goes away from the normal. In the exam, if you write towards the normal, okay, how we can easily verify whether it is away from the normal or not? We'll just extend this line, incident ray. If you extend this line, okay, whatever you write right side, that will be away from the normal. If it is left side, it is towards the normal. In that case, we will deduct the marks. We will just extend this line like this. This reflected ray should be away from it. Okay, that means away from the normal. If it is somewhere here, it will be considered towards the normal. It is wrong because the speed is getting increased. If the speed is increasing, it will go away from the normal. Then second ray, the angle B is 48 degree. Critical angle is 48 degree. If it is 48 degree, angle of incidence is equal to critical angle, then it undergoes refraction at 90 degree. It undergoes refraction exactly at 90 degree. That is nothing but on the surface of the medium. This is the surface, correct? The refraction will be on the surface. Okay, next, this ray C clearly shows that the angle of incidence is more than 48 degree. So at this point, you have to draw a normal and it undergoes total internal reflection. So in total internal reflection, whatever the angle here we have, assume more than 48 means it can be anything, 49, 50, 80, 60, anything. Okay, whatever the total angle of incidence, that will be equal to angle of reflection. Keep this in mind. Okay, so this is about this question. We have one more sub question. Name the phenomenon which the rays A, B, C exhibits. Very good. Okay, this is A. Okay, in question B, A, this A undergoes just refraction. A exhibits refraction. You can just write A hyphen refraction. B, so B undergoes critical angle. Okay, refraction. What is exhibits means refraction at 90 degree. A, just refraction. Okay, you just have to write refraction. B, refraction at 90 degree. In the bracket, you can write it as critical angle. Then C, okay, C, total internal reflection. Total internal reflection. This is what they are asking. A, refraction. B, refraction at 90 degree. C, total internal reflection. That's it. Our next question, for this figure, P is the source, PR and PQ are the rays, and this is based on this diagram we have many questions. First we'll go one by one. State the special name given to the angle of incidence PQN. PQN of ray PQ. For the ray PQ, what is the special name given for PQN? PQN, whenever we are talking about three terms, that means we are talking about the angle PQN. That means, see, answer for sub question A is critical angle, correct? Critical angle, because it is clearly showing the refracted ray at the surface of the water, correct? This is water and this is air medium. So based on this only I have written critical angle, because we know critical angle of, if the angle of incidence is equal to critical angle, then only the refracted ray will be 90 degree. It is clearly mentioned in the diagram that the refracted ray is on the surface, so it is nothing but critical angle. Second, what is the angle of refraction for the refracted ray QS? Where is the QS? What is the angle of refraction? So that is 90 degree. So for B question, the answer is 90 degree. See, if you know the concept, this is how you can easily answer the questions. Name the phenomenon. Third one, name the phenomenon that occurs if the angle of incidence, PQN is increased. We got to know PQN is critical angle. So they are specifying that if the angle of incidence is increased compared to the critical angle, if the angle of incidence greater than the critical angle, what happens? It undergoes total internal reflection. That is what they are saying. Name the phenomenon. Total internal reflection. In the exam, if you write TIR, then you will not get MARKS. That's it. Okay. Then we'll go for question D. Okay, question D first we'll read it. The ray PR suffers partial reflection. PR suffers partial reflection and refraction on water air surface. Why? Because we know, see, in a normal refraction, whenever you are drawing a normal refraction, it undergoes both reflection and refraction, correct? And that is what they are asking. Why? Because very simple, the angle of incidence for question D. Okay, the angle of incidence, you have to write the answer in the form of sentence. The angle of incidence is less than the critical angle. It is less than the critical angle. If the angle of incidence is less than the critical angle, it undergoes partial reflection and refraction. This is the reason. Okay, it undergoes refraction as well as reflection. What is the reason? The angle of incidence is less than critical angle. Here to mention it specifically for this question, okay, angle of incidence, you write it in the form of sentence. Angle of incidence is less than PQN. Okay, is less than angle PQN. That is nothing but critical angle. This is how you have to write for this question. For any question, this is the answer. Both are correct. So you have to write it in full form, sentence form. Next, last question. Draw the diagram, the refracted ray for incident ray PR. Hence, show the position of image of an object P by a letter P dash when seen vertically from above. When this, okay, we are going to talk about only PR. When it is seen from some, okay, vertically above, somewhere here, okay, where will be the image? Very simple. See, these are the incident rays, correct? So first, if a ray goes like this straight, okay, it will, after refraction, it will not undergo deviation, correct? But because of this one, we know it is from denser to rarer. It goes away from the normal. Whenever a person sees it, okay, person see the ray, then they'll see, just expand this ray. So here we are going to get the image. This is what they are specifying it to use P dash. Wherever we see P dash, that is the thing. But the image, see, whenever we are talking about only PR, correct? Only PR. We need this line just to show where the image is forming. So if it is going straight, it goes undeviatedly. When PR, it undergoes refraction. Whenever person sees, okay. So See one thing, arrow marks, whether it should be towards the eyes or towards the object, like this ulta. Okay, always the arrow mark should go from object to eyes. Object to eyes. These arrow marks are correct. If you write ulta, that is completely wrong. So the refracted ray, if you expand this refracted ray, okay, extend this refracted ray, wherever you see a point, there the image will be formed. There we are going to write it as p dash. That is what they have mentioned. This is the answer for this question. Our next question, the refractive index of glass is 1.5. From a point P inside a glass slab, draw rays PA, PB, PC incident on the glass air surface at an angle 30, 42 and 60 respectively. So first we'll complete the diagram until what they have said. Listen, from point A, okay, there are three rays has to go. First one is 30 degree, okay, second one 42, third one 60. So while drawing the ray diagram, use scale. If they get to know you're not using the scale, that means they are not going to give you any marks. Keep that in mind for any diagram in physics. Okay, it should be neat. Okay, you should not use free hands to draw the diagrams. Next, so this one is 30 degree, so they have told us to mark PA. Okay, then this one is 42, this is B, and this one is 60 degree, and this is C. So if I extend this one glass slab, we can aram see what is going to happen. Okay, now till here this is the question, but in the question they have not given the diagram also. This is also we have drawn. Okay, from point P, PA 30 degree, PB 42 and PC it is 60 degree. Till here we have done. Next we'll go for the question. In the diagram, show the approximate direction of these rays as they emerges out of the block. Okay, listen, we know what is the critical angle for glass. That is what we have learnt in concept video. That is why I always suggest watch the concept video first. Critical angle for glass is 42 degree. Whatever, if the angle of incidence is equal to the critical angle, the refraction we know. Okay, first we'll go for this one. For 30 degree, okay, anyhow it is going from denser to rarer. It goes away from the normal. Away from the normal. Next, this one, angle of incidence is 42, that is equal to critical angle. If the angle of incidence is equal to critical angle, then what happens? Refraction will be there on the surface, and that will be exactly 90 degree. That will be exactly 90 degree. And third one, it is more than critical angle. Critical angle of glass is 42 degree. Now the angle of incidence is 60, more than the critical angle. So it undergoes total internal reflection. Whatever the angle we have here, okay, the same angle, you have to use the compass. Okay, then only you will get the proper diagram. Okay, this is part A. Part A is done. Next, okay, take 42. Okay, sin 42 as 2 by 3. This is given in the question. Next, refractive index is also given. Okay, then angle of incidence is equal to 42. We need to find what? Angle of refraction, that is the question mark. Okay, here first I'll show you what is the wrong method the students will take while solving these kind of questions. Okay, now listen, very simple. First we'll go for the wrong method, then I'll show you the right method, then only we'll understand it properly. See here, so sin angle of incidence, angle of refraction and refractive index is related to Snell's law. That is nothing but sin I by sin R is equal to mu. Correct? We need R. So send this R that side, sin R that side, complete this part that side, and refractive index this side. Then final will be sin I divided by mu is equal to sin R. So we'll substitute the answer. Sin I is nothing but 42. I is nothing but 42 degree. So in the question itself they have given sin 42 degree is equal to 2 by 3. So this is equal to 2 by 3 divided by mu, right? Mu is nothing but 3 by 2 is equal to sin R. Okay, sin R. So this one, if you take properly, 2 by 3 into 2 by 3, answer will be 4 by 9. 4 by 9. So if you take this one as a decimal, okay, decimal, whatever the answer you get, you will look at the trigonometric book for what answer, for what decimal, what is the corresponding angle, correct? That will be completely wrong. That will be completely wrong. Okay, I'll show you the right method. What is the main problem with this one? Even though everything is correct, what is the main problem with this one? See, once you get this answer, what we are going to do, convert this one into decimal. Assume we'll get 0.4 for what value of 0.4, what is the sign, corresponding sign angle, so that we will select, correct? That will be completely wrong. This is where you are going to do. Here one trick is there. Here whatever the refractive index they have given, this is from air to glass. Air to glass, light has to enter from air to glass, but here what is happening, the light is entering from glass to air, then we should not use sin I by sin R, we should use sin R by sin I. Sin R by sin I is equal to mu, then only we get the proper answer. This is the major mistake the students are going to do. So that is why we have to see whether the light is coming from air to glass or glass to air. Refractive index is always whatever the refractive index they'll give for a glass or water, whatever it might be, okay, it is always from air to that medium. Okay, but when the light is going from this angle, okay, ulta, from that medium to air, okay, glass to air, water to air, diamond to air, whatever it is, whatever the refractive index, this formula, okay, it will become sin R by sin I. Very simple, that's it. If the ray is coming from air to glass, this is the refractive index and this is the formula. If the light is going from glass to air, then the same formula I have to take the reciprocal. The final formula will become mu is equal to sin R by sin I. That formula we have to use, then we will get the proper answer. Now we will see the proper method. See, so mu is equal to sin R by sin I. This is the formula. Why we have to use this formula? Because this is not Snell's law, correct? But the light is entering from glass to air, denser medium to rarer medium. That's why we have to interchange. Then one, see, mu we can take it as 1.5 is nothing but 3 by 2. We can take it as 3 by 2. So mu is equal to 3 by 2. We need sin R. So send this sin I that side. Sin I, that is nothing but sin 42. Sin 42, see, I is given as 42. So sin 42, in the question itself they have given 2 by 3. So take 2 by 3 is equal to sin R. Okay, 2 get cancels, 3 get cancels. Answer will be 1, sin R. So in the trigonometric book, for what value of 1, for 1, what is the corresponding angle? If you have to see sine trigonometric function table only, you should not see cos or tan. Okay, so most of the time in mathematics we use tan theta, so don't go for tan page, you have to go for sine page. In sine page, for what, okay, for 1, for a value of 1, what is the corresponding angle? That will be 90 degree. So if you get 1, that is nothing but 90 degree. So R value, okay, angle of refraction will be 90 degree. That's it. This is how you have to solve. So these kind of questions you have to be very careful. Our next question, a ray of light enters a glass A, B, C, D. So this is A, B, C, D. Okay, as shown in the figure, or else you can take this as CD. Okay, figure, and strikes the center O of the circular part AC. This is AC, correct? This is the circular part. Critical angle for glass is 42 degree. Okay, this is given, and complete the path of okay, ray till it emerges out of the glass slab. Mark the angles in the diagram wherever it is necessary. Okay, so here very simple question, right? So this is angle of incidence is 42 degree normal. If it is angle of incidence is 42 degree, that is nothing but critical angle. So if the angle of incidence is equal to critical angle, then the angle of refraction will be 90 degree, correct? So this is where many students go wrong, completely wrong. Why? Because I'll show you. This is the normal. Okay, what angle is given? Angle, this angle is given. What is the angle of incidence? Angle of incidence is nothing but angle between the incident ray and the normal. This is the angle of incidence, not this one. See, in many websites and in many PDF solutions, they have given the wrong answer. So always verify from the textbook and learn. Okay, so this angle is given. This is not the angle of incidence. What is the angle of incidence? Angle between the incident ray and the normal. This is the normal, right? You know how to draw the normal. Now this is the angle of incidence. So this complete angle is 90 degree. If some part is 42 degree, this will be 48. Okay, this complete angle, normal means from the surface to this normal, it is 90 degree. Some part is 42 degree, this part will be 48 degree. So now this is what important. Now okay, critical angle is 42 degree. Now what is the angle of incidence? It is more than the critical angle. What happens? It undergoes total internal reflection. It undergoes total internal reflection with the same angle, 48 degree. So we have to draw it until this ray emerges out. So here the important part is, listen. So what is, see here, when it hits the surface, for this surface we have to draw the normal again. Now we have to see this angle. Correct? Because the angle between now this acts as an incident ray for this surface, correct? So this will be the incident ray. Many students will get confusion which angle they have to see, whether this angle or this side, the other side. You have to see the angle between the incident ray. This is the incident ray for now, and this will be the normal. You have to see the angle between these two. This is what I have explained in concept video. When it comes to prism, okay, and these kind of questions, you have to be very careful, very easily. If you know the condition and proper knowledge, you can also get 4 to 3 marks. Okay, 3 or 4 marks within 30 to 40 seconds. Okay, listen. We have to get this angle. So what I have taught in concept video, first find the triangle. Where is the triangle here? This triangle is not required. So this is not even considered as a triangle. Then this part is not triangle. Here we have the triangle. So first find the angles of the triangle. This is what we have learned. If this is 48, this will be 42. Correct? For complete, see, from this line to complete till the surface, it is 90 degree. Correct? 90 degree. Some part is 48. This will be 42. Okay, this will be 42. And you see here and here straight line. So this will be 90 degree. Okay, 90. What is the total angle of a triangle? 90. Total is 180. So 90 is done. 42. And how much is remaining? 48. This will be 48. This will be 48. And we know from the normal, see, from this line to here, it is completely 90. Some part is 48. This part will be 42. This is how we are going to find the angle. Very important. Okay, if you don't know this logic, that means you have not seen the concept video. If you haven't seen, then this part, okay, whatever we are learning is of no use, because you don't know the technique only, how to find the angles. That is what I have taught in the concept video. Now, angle of incidence is equal to critical angle. Angle of incidence is equal to critical angle, and this is the normal. This is the surface for now. So refracted ray will go like this on the surface. Why it is on the surface? Because angle of incidence is equal to critical angle. See, for few students it might be little confusing, so go back and rewatch it. Whatever the question you see, okay, if you get little confusion, just go back, rewind it and come back, see it again, you will definitely understand. So this is the emergent ray. So in many this one solutions and website, the emergent ray will be here only. That is completely wrong, because what is the angle given? That is not the angle of incidence. Completely wrong. This is what we have to select. Okay, so get the proper knowledge, then only you will get the full marks for any question. Our next question: what is total reflecting prism? State 3 actions that it can produce. Draw a diagram to show any one action of the total reflecting prism. Very simple question. Listen, what is total reflecting prism? So total reflecting prism is a prism where the angle of the prism is 90 degree. Okay, I'll show you the diagram. Okay, along with the this one definition, if we learn the diagram also, it is very good. It is easy to understand. Okay, assume this is the prism, total reflecting prism. So the prism which has angle of refraction or refracting angle as 90 degree at the middle, and other two reflecting surfaces, other two refracting surfaces are each 45 degree. This is called as total reflecting prism. Okay, this is the definition. Next, they are asking state three action that it can produce. First, see, it can deviate a light through 90 degree. It can deviate a light through 0 degree. It can deviate a light through 180 degree. This is what we have learned in concept video. These are the three rays it can produce, and they are asking us to draw any one. Okay, any one. See, we can go it for anything, we can go for anything to deviate a light through 0 degree, 90 degree, 180 degree. We can select any one. Very easy, to 180 degree we'll go for that. See, assume this is the incident ray. So as the angle of incidence is 90 degree, it passes straight without deviation. Okay, here, okay, here, see, again this is 45, this is 45. Again we have to find a triangle. Whenever we want to find the angle, what angle you have to find, that you should know first. This is the normal, this is the incident ray now, for now. So angle, this angle we want, correct? This is what you need to understand, which angle you need to understand. From the, see, first start with the normal and the incident angle between them, that is what we have to find. This is 45 degree, is coming straightly. This is 90 degree, correct? 45, 90, and this will be again 45. 45. If this is 45, this will also be 45. If the angle of incidence, is greater than critical angle, what is the critical angle for glass? 42 degree. It is more than the critical angle, so total internal reflection, okay, with the same 45 degree angle, 45, 45. Now here you have to draw the normal. If this is 45, see, again find the triangle. This is the triangle, right? If this is 90 and this is 45, see, whatever the angle we have here, the same angle will be equal to this one. So this is also 45, this is also 45, so this will also be 45. If this is 45, this will also be 45. Again it is greater than the critical angle, so total internal reflection, okay, again it is the surface, it is exactly on the normal, correct? Normal means we can draw the normal here only, on the normal, so deviates like this. So this is the deviation of, okay, to deviate a light ray through 180 degree. Okay, so here deviation is equal to 180 degree. That's it. Our next question, show with the help of diagram how a total reflecting prism means 90, 45, 45 can be used to turn a ray of light through 90 degree. This we have already learned in concept video. Again we are going to do it here because there is one more sub question. Name one instrument in which such a prism is used. Very simple. See, total reflecting prism, that you should know. Okay, total reflecting prism means one angle should be 90, other two will be 45. See, this is 45, okay, 90, and this is 45. Okay, now to get, okay, 90 degree deviation, the light has to enter in this way. Light has to enter this way or this way, anyway is fine. So assume we are going to incident a light like this. So anyhow this is a straight line, the angle of incidence will be exactly 90 degree, correct? This is the, it is exactly on the normal, so it passes without deviation, correct? It passes without deviation. Now this is the incident ray. Where is the normal? Where will be the normal? See, how to draw the normal? This, if you don't know this one only, then it is you will not understand anything. Okay, so to draw the normal, it is very simple. Wherever the surface, this is the surface, right? So if this is the surface, keep the protractor, okay, protractor like this, the center, okay, for 90 degree you draw a straight line, that will be the normal. So now we want it here, correct? Keep the protractor at this point, center of the protractor at this point, keep the protractor like this, wherever the 90 degree is showing, assume here, so draw it like this. This will be the normal. Okay, now what angle we want, that is important. This is the incident ray and this is the normal, this angle we want. Okay, so how to find this one? See, we know this is 45. First find a triangle, that is important. First find a triangle. Whenever you want to find the angle, first find a triangle. 45 and this is 90, this will also be 90, correct? So see, because it is passing straight, so the angle between this surface and this ray will be 90 degree. If this is 90 and this is 45, other angle will be 45, because total angle should be 180 degree. So this will also be 45. And we know from this surface, okay, to this normal, it is 90 degree, correct? From this surface to this normal, it is always 90 degree. That is why we draw the normal. So whenever we draw the normal, it will divide into 4 parts. First part, this part; second part, third part, fourth part. All the parts will be 90 degree. So if this is 45, this will also be 45. For a glass prism, what is the critical angle? 42 degree. What is the angle of incidence? 45. More than the critical angle, so it undergoes total internal reflection. At what angle? Angle of incidence will be equal to angle of reflection. Okay, so this is 45 done. Now it is at this surface. Anyhow, this is a straight line, correct? Straight line, we can aramse draw the normal. See, if you don't know how to draw the normal, again at this point, keep the protractor like this, 90 degree, draw a line. So the ray, incident ray, is on the normal, means it goes without deviation. See the incident ray here, deviation here, correct? So what is the total angle between them? 90 degree. So deviation to 90 degree. Done. This is the diagram they are looking for. All these things we have learnt in concept video also. Here also, just make sure your knowledge is getting stronger. Next, we are asking for one prism or one instrument where we are using this kind of prism. Periscope. See, if you don't know periscope, that means you have not seen the concept video. See, it will be like this. So here we are going to place the prism. Okay, so if you place it like this, we use it in submarines. Assume this is where you can see, this is your complete body height. This is where your eyes are. So when you use prism, whatever the light, okay, it enters here, it hits here, comes to your eyes. Okay, that is why we use a prism in a periscope. This is the instrument, that is nothing but periscope. That's it. Our next question, the ray of light xy. See, this is the ray xy. See, this question is different. Okay, why we are using textbook now? Because we are using the latest edition, 2025 edition textbook. In that, some questions are changed and some are upgraded. That's why this is an upgraded question. Now see, a ray of light xy passes through a prism, right angled isosceles prism, as shown in the figure. Okay, now what is the angle through which angle of incident ray and deviates and emerges out of the prism? So for this one, you need to understand what is angle of deviation, what is angle of emergent. Listen, what is angle of deviation? You first join, you have to see where is the junction point. Junction point means the intersection point of incident ray and emergent ray. That is the angle of deviation. Keep this in mind. What is angle of deviation? The junction point or the intersection point between the incident ray and the emerges. This is the emergent ray, correct? Where these two are meeting here. What is the angle? This angle is the angle of deviation. So here angle of deviation is 90 degree. Then angle of emergent. What is angle of emergent? Whenever the ray is going out, what angle it is making? It is making 90 degree. See, correct. This is the given diagram. So angle of deviation is equal to angle of emergent. So first question is done. Okay, next, name the instrument where this action of prism put into use. Previous question we have learned, this is nothing but we are using in periscope. Then third one, which prism surface will behave as mirror? The surface AB. Okay, why? Because see, which surface of the prism will act as mirror, where we are getting the total internal reflection. That is important. We are getting the total internal reflection at this part, right? So wherever we are getting the total internal reflection, that part will behave as a mirror. So which part? See, second one is periscope, third one is surface AB. So here we are getting total internal reflection, right? So which is this surface AB. That's it. Our next question, draw a diagram of a right angled isosceles prism which is used to make an inverted image erect. So this is what exactly we have learned in concept video. So anyhow, there is no small change in the question. That's why we are going to skip this question because we have learned in concept video. Our next question, in the figure, a ray of light PQ incidented normally on hypotenuse of a isosceles right angle prism ABC. See, here in this question they have given the diagram. If this diagram is not given also, you have to know how to draw this one based on the given data. A ray PQ, this is PQ, okay, incidented normally on the hypotenuse. So where is the hypotenuse? This is the hypotenuse of a triangle. What kind of triangle? Isosceles right angle. Isosceles means if this will be pakka 90, this will be 45, this will also be 45. This we need to know. Right angle, okay, isosceles right angle prism. Now we have to complete the part, that is question A. Remaining questions will solve one by one. Okay, now this is the incident ray. So straightly it will go. Why straightly it is going? Because the incident, okay, this is the 90 degree. If it is 90 degree, it passes without deviation. Now this is the angle. Now first, whenever you see this point, draw the normal. Okay, which angle we need, that is important. This angle we require, because always from the normal and the incident ray, the angle between those two, that is what we have to find. How to find this angle? Very simple. If you have seen the concept video and previous questions and all, this is very easy for you, but it is a big procedure. We have to keep on finding the angles. That's okay. If you follow the procedure, you can find any angle. Now listen, if you want to find this angle, find a triangle. Whenever this ray incidents, okay, divides the big triangle into many parts, correct? Out of these parts, where is the triangle? This is not a triangle, this is the triangle, correct? So first we find the angle of triangle, then this will be, this we can aramse find. Listen, now we got to know this is 45, and if this is 90, this will also be 90, correct? If this is 90, this is 45, this will also be 45. Why 45? Because total angle of a triangle is 180 degree. 90 plus 45, 135. Remaining will be 45 only. Now we know, listen, why do we write normal here? Because this side will be 90, this side will be 90, this side will be 90, and this side will also be 90, correct? This side will also be 90. If this side is 90, some part is 45, the remaining part will also be 45, because 45 plus 45, the complete angle will be 90. Now we got this angle. So what is the angle of incidence now? 45 degree. If the angle of incidence is 45 degree, okay, then that is nothing but more than the critical angle. So it undergoes total internal reflection with the same angle, 45 degree. Okay, now it has hit here. Again at this point, draw the normal. Again, if you get the confusion at this point, keep the protractor. Okay, you can keep it here or here, anywhere, the center point, okay, wherever it is showing, draw a normal dotted lines, that will be normal. So now again, from the normal and the incident ray, this angle we require. How to find this one? Again, find the triangle. This is the triangle, correct? This ray has divided this part into triangle. So this is 90 we know, and if this is 45 degree, see, this is 45, this will also be 45. If this is 90, 45, this will also be 45. Okay, now why do we require this one? Because this complete angle, okay, from the normal, see, inside this one, from the normal till here, it is 90, some part is 45, this will also be 45, correct? Now you have to keep on practicing, then only you will get these kind of questions properly. So angle of incidence is greater than the critical angle, so total internal reflection with the same angle 45. Okay, now see here, this angle is important. Now again, this is 45, so this complete, okay, again we have to find the angles of a triangle. One is fine, 45, it is already given. Next, this complete, see, this complete angle is 90, some part is 45, the remaining part will also be 45. If this is 45 and this is 45, total angle of a triangle should be 180. 45 plus 45, 90, remaining angle will be 90. So whenever you are drawing 90 degree, don't draw it like this curved angle. It has to be like a box. Okay, this is 90. If the angle of incidence is 90 degree, okay, because you draw the normal will be on the line only, because you keep a protractor here at this point. Okay, at the center point you have to draw the normal. It is on the normal, so it passes without deviation. Now, how to find the angle of deviation? Very important and simple concept. Listen, many students will get confused here only. See, I'll explain everything. What are the possible ideas? If the ray is coming here and without deviation it is going out. See, if a ray is coming here and it goes in the same direction, okay, then it is angle of deviation is 0. Angle of deviation is 0. Next, if a ray is coming here and it is going perpendicularly, the angle of deviation will be 90. So here it is coming here 190, again one more 90. Okay, so it is going in the same path. If where the ray is coming in the same path it is going, that means the deviation will be 180 degree. So we have 290 degree. 190 degree it will take a turn like this. One more 90 degree it will take U-turn. Okay, whenever you see a U-turn, that is deviation is 180 degree. If you see any perpendicular, okay, only one sharp turn, okay, whether in this direction or in this direction, any direction, angle will be 90 degree. And whenever a ray comes here, whatever happens here, if it goes in the same direction, deviation will be 0. For this question, deviation is 180 degree. Now, second question, first A is done. B, they are asking for what is the deviation of PQ, that is nothing but 180 degree. Why? Because it is taking U-turn. Okay, whenever it is taking U-turn, it is 180 degree. Name the device which this action is used. See, in question number 10, it was the angle of deviation was 90 degree. The instrument which we used is periscope. Here, whenever it is taking U-turn, whenever the deviation is 180 degree, we use it in binoculars. So answer for C is that. Our next question, in the figure, a ray of light PQ incidented normally on the face AB. Okay, this is A, this is B, and this is C. See, if you know the procedure, whatever the question, whatever the angle, whatever the prism they give, okay, if you know the procedure, we can aramse draw the diagram. Okay, we can aramse complete the diagram. Next, PQ is incidented normally. Normal means on the normal line. So if you keep a protractor here, the center point, you draw a normal, right? So on the normal only the ray of light is incidented on the face AB of an equilateral glass prism. Equilateral prism, they only give that we have to take these angles. Okay, equilateral prism means 60, 60, 60. Complete the ray diagram showing the emergent ray into the air after passing through the prism. Okay, we just required to complete the diagram. Then take the critical angle of the glass is 42 degrees, that we know already. Next, we have so many questions. Write the angles of incidence at the face AB and AC. Okay, we'll do that. Next day we have one more question. First we'll solve this one. Okay, first we'll complete the diagram. Now listen. Whenever a light incidenting, okay, on the normal or angle of incident on the surface, okay, is 90 degree, it passes without deviation, correct? So now wherever it hits the surface, keep the protractor, okay, or any, see, without protractor also you can draw. So here you keep the protractor, center point you draw the normal, that's it. Now what angle we want? This is the incident ray and the normal, this angle we require, correct? How to find this one? Very simple. Listen, first find the triangle. This is not a triangle, correct? This part, whenever this line divides this complete triangle, okay, we have to see the triangle. Where is the triangle? This is the triangle, correct? Because we cannot say this is the triangle. So this is the triangle. Now you know this is 90, so this will also be 90. Okay, 90 plus 60, 150, and this angle will be 30 degree, correct? This angle will be 30 degree, because total angle of a triangle will be 180 degree. 90, 60, 150, this will be 30. Now if, see, why do we draw normal? This is 90, this is 90, this will be 90, and this will be 90, correct? So this will be, all those four parts will be 90. Now we got this angle, okay, this complete angle is 90. See, this from this surface complete angle till the normal is 90, some part is 30, this will be 60. So what is the angle? 60. It is more than the critical angle, so it undergoes total internal reflection. So here again, so at 60 degree only, because total internal reflection, angle of incidence will be equal to angle of reflection, so it undergoes reflection. Here again it is going in a straight line, so here it is nothing but you keep the protractor, draw the normal, so the line, the emerging ray, okay, will be, it is on the normal, so it goes without deviation. So diagram is complete. Write the angles of incidence at the face AB and AC. So here we have to be very careful. Few students will go wrong here only. Okay, they are asking for angle of incidence at AB. See, we know angle of incidence is nothing but angle between the incident ray and the normal. In AB, it is clearly mentioned in the question that, okay, it is incidented normally. If the ray is incidented normally, okay, at AB, it will be angle of incidence will be 0 degree. Keep this in mind. It is not 90 degree. It is making the angle between the surface and the incident ray. Okay, but here we are talking about incident angle. Angle of incidence or incident angle is nothing but angle between the incident ray and the normal. If the incident ray is on the normal, angle will be 0 degree. Keep this in mind. Next, AC. Okay, AC here, see, this is AC. Okay, the angle it is making is 60 degree. That's it. Okay, we have one more sub question. Name the phenomenon which the ray of light suffers at the face AB, AC and BC. Okay, AB. Okay, here refraction, correct. Here it is undergoing at AB surface. Okay, we have to name the phenomenon. AB, it is just refraction. So refraction. Next, AB is done. Next, which is that? AC. This is AC. So here only we are getting the total internal reflection, right? So AC, total internal reflection, TIR, but in the exam you should not use the short forms. Next, at BC, see here BC also just going, it is undergoing refraction. So refraction means there should be change in angle, but here there is no change in angle, but it is undergoing refraction. Okay, that is nothing but BC refraction. See, first we need to find where is the total internal reflection. Apart from that, everything will be refraction only. Okay, only at surface AC we are getting the total internal reflection. Apart from that, everywhere it is just refraction. The previous question, that is question number 13 and question number 14, almost similar because the triangle, okay, equilateral triangle is same. Angle of incidence, it is 90, the angle of incidence is also 0 degree, that is nothing but 90 degree it is making with the surface of the prism. So in previous question, this ray was here, but now it is here. That's it. Follow the same procedure, you'll get the same answer. The diagram will be little different compared to that because the incident ray, okay, this was somewhere here, now it is here. You follow the procedure, you'll get the same answer. Our next question, draw a neat label diagram to show the total internal reflection of a light normally incident on one face of 30, 90 and 60 prism. See, this question exactly we have solved in concept video. See, if there is any small change, okay, then we can aram say draw it. Whenever they give the diagram, we can aram say complete it. This question we have solved exactly, okay, without any difference, okay, in the concept video. That's why I'm suggesting you to watch the concept video. If you have watched it, then you can aram say skip it because you have already learnt it. Our next question, what device other than a plane mirror can be used to turn a ray of light through 180 degree? The diagram, and we have named the instrument. That is, we have one more question. We'll go one by one. What device other than plane mirror can be used to turn a ray of light through 180 degree? This question we have solved earlierly. Okay, in the same exercise problem. Again we are going to do it because it's a different kind of questions. Okay, the angle was different there. See, whenever the question is same as the concept video, that only that question we are going to skip. This question, the angle is same, Okay, again we have learnt in concept and one of the questions again, but here they have added some more questions, so we are going to do it now. What device other than plane mirror can be used? See, very simple. Total reflecting prism. Total reflecting prism is used to deviate a ray through 180 degree. Okay, that is what we are going to do it here. Assume this is the triangle. What is total reflecting prism? We have learnt in one of the questions. One angle, this angle should be always 90 degree. This angle should be always 90 degree. Okay, then if this is 90, this will be 45 and 45. This is what we have learnt. Total, okay, reflecting prism means the refracting angle or angle of refraction, okay, should be 90 degree, and other two surfaces angle should be each 45 degree. This is total reflecting prism. Now that is what device other than plane mirror? Answer is total reflecting prism. Okay, total reflecting prism is the angle. Answer. Then we have to complete the diagram. We have one more question. Okay, now listen. Whenever we need to get, okay, 180 degree, we have to incident the ray from here. Okay, we have to incident the ray from here. So if you incident the ray from here, you will not get 180 degree, you will get 0 degree deviation. Okay, this is what we have learned in concept. See, if you incident it like this, you will get the ray here only. So it is passing just like that. Okay, something will happen here, but inside some whatever happens, we don't care. Outside, this is incident, emergent. Okay, what is the angle? So if it is going in a straight line, 0 degree. If it is taking U-turn, then it is 180 degree. If it is just taking only one turn, okay, one right or one left turn, then it is 90 degree. Okay, so now they are asking for 180 degree. That is what we are going to draw. For 180 degree, it has to come from 45 degree surface. The incident ray should be between 45 and 45. Now here, okay, then for this angle, see, if this is straight, completely straight, this will be 90 90 90 90, correct? So it goes straight. Next, so instead of doing that, we can move this one so you can understand it properly. Okay, so assume the incident ray is here, somewhere here. So if it is incidented normally, so keep the protractor at the center point, draw the normal. So the incident ray is on the normal, so without deviation it moves, correct, like this. Now, so here wherever it touches, draw the normal. So on this surface it is touching, right? So keep the protractor. Okay, keep the protractor wherever, okay, keep the protractor wherever it is showing. Okay, keep the protractor like this, center point, you draw the normal. What angle we want now? From the normal to incident ray, this angle we required. We don't know what is that angle. So where is the triangle? Whenever this light, okay, this ray is separated this prism, where is the triangle? See, this part is not the triangle, correct? This is the triangle, correct? So first find the angle of the triangle. Done. This is 45. This is, or also we can say this is 90. 45, 90, 135. The remaining angle of this triangle is 45. Okay, if one is 45, one is 90, other will be 45. Keep this in mind. Okay, now what do you mean by this? This is 45. That means from this surface, see, why do we draw the normal? This is 90, this is 90, this is 90, and this will also be 90. This complete angle from this part to till normal, it is 90. Some part is 45, the remaining part will also be 45, because this is completely 90. Okay, out of 90, one is 45, the remaining will also be 45. Now what happens? The angle of incidence is 45, that is greater than the critical angle. So it reflects with the same angle. It reflects with the same angle, 45 degree. Again, at this point it is touching. Draw, keep the protractor at the center, you draw the normal. So this is incident ray, this is the normal, this is the angle we want. Where is the triangle? So here, this is the triangle, correct? This, because of this line, this is the triangle. This is 90. Okay, this is 90, and we got to know, see, from this part, from this normal, this was the normal, right? From this normal to here, it was 90. Some part is 45, this will also be 45. 90, 45 means this will also be 45. So this is completely 90. If this part is 45, this will also be 45. If it is more than critical angle, this is the angle of incidence. If it is more than the critical angle, total internal reflection with the same angle, because reflection means angle of incidence will be equal to angle of reflection. So it is passing straightly. Keep the protractor here, draw the normal. It is passing, okay, now the incident ray and the normal both are same, so without deviation it passes. Without deviation it passes. So here angle of deviation is equal to 180 degree. If it is taking U-turn, deviation will be 180 degree. Now they are asking one more question. This we have already solved. Name the instrument in which device is used. See, if the deviation is 180 degree, answer will be binocular. Answer will be binocular. If the deviation is 90 degree, then the instrument which we are using this kind of prism is will be this one, periscope. So if the deviation is 180 degree, binocular. Deviation is 90 degree, periscope. That's it. Our next question, two isosceles right angled prism. Isosceles right angled prism. Okay, so isosceles means this will be 45, 45, this will be 90. Okay, this is also like this is 90, this is 45, this is 45. This is what you have to do once you get to know what kind of triangle prisms are there. Okay, isosceles right angle prism P and Q are placed near each other as shown in the figure. Complete the path of light. So the light is coming from this angle. Okay, so this is okay, this is the angle, and we have to complete it until it comes out, emerges out of the second prism Q. Okay, very simple question if you know the concept. Listen, this is the surface. See, this is a straight line, correct? This is a straight line. Keep the protractor and draw the normal. Now the incident ray is on the normal, so it passes without deviation. Okay, without deviation wherever it is touching. Okay, from this is the surface, right? Keep the protractor here, keep the protractor. Okay, draw the straight line from the center. This is the normal, and this is the angle we require. This is the angle we require. To find this required angle, we need a triangle, correct? See, this line has divided. We need to search for a triangle where this line has divided. Okay, this line has divided this complete prism, okay, the complete triangle into the one triangle, one other part, okay, different shape. So this is the triangle we required. This is 45, this is 90, this will be 45. Okay, now this complete angle is 90, correct? From the surface, see, this is 90, this is 90, this is 90, and this complete angle is 90. Out of 90, some part is 45. This will also be 45. 45. If the angle of incidence, okay, is 45, that is nothing but greater than the critical angle. Whenever they talk about glass, okay, any material, glass, okay, made up of glass, the critical angle will be 42. Keep this in mind. So angle of incidence is 45, more than the critical angle. Total internal reflection with the same angle, Now it goes like this. Okay, here this is a straight surface, right? So keep the protractor, draw the normal. The incident ray is on the normal, so it passes without deviation. So wherever it touches, put the protractor at the center, draw the normal. This is the angle we require. So correct, I am going little bit faster because we have solved so many questions. This is the angle we require. This line has divided this complete triangle into one triangle, one other shape. See, this is not the triangle, so this is the triangle. This is 45 and this is 90, correct? Straight, this is also straight, this is also straight, 90, 45, 90, and this will also be 45. Okay, this is the normal, means 90, 90, this is 90, and this half is 90. The complete half is 90, out of which half is 45, then this will also be 45. If this is greater than the critical angle without deviate, okay, complete total internal reflection with the angle 45 degree. Now again it is straight, so keep the protractor here, normal, this ray is on the normal, so without deviation it passes. That's it. This is the diagram they are looking for. Our next question, complete the path of a ray PQ through the glass prism ABC shown in the figure till it emerges out of the prism, given the critical angle of a glass prism is 42 degree. So first we have to draw the angles of the prism, then only we have to start the diagram. See, angle of the prism, that is given. If this is not mentioned, the square means or box means it is 90 degree. Okay, if this is 90, this is 30, this will be 60, correct. Why? The complete angle of a triangle should be 180 degree. Now see, 60 plus 90, 150, 150 plus 30, 180. So now it is correct. So 90 plus 30 plus 90, 120, that should be 60, then it will become 180 degree. This is our first step. Okay, then we have to start the diagram. Now wherever the ray is touching, keep the protractor, draw the normal. Draw the normal. Now we got to know the normal. Okay, the incident ray is on the normal, so without deviation it goes, touches the surface here, and wherever it is touching, keep the protractor, center, from the center draw the normal, correct. So which angle we require? This angle. Why this angle? Because this is the incident ray, angle between the normal and the incident ray only we want. Okay, next we don't want this one. Okay, but to find this angle we need to find these angles, because we have to see the triangle. This ray is splitting this complete big triangle into one small triangle, one other shape. We don't want other shape, we always want triangle. So this is 60, this is a straight line, this is 90, means this will also be 90, this will also be 90. Okay, if this is 90, 60, this will be 30. Okay, why do we draw this normal? Just to get the angle, reference angle. So this is 90, this is 90, this will be 90, and from this normal to this surface it is 90, from this normal to this surface it is 90. So some part is 30, out of 90 some part is 30, remaining part will be 60 degree. So now this is the angle of incidence. If the angle of incidence is greater than the critical angle, what happens? It undergoes total internal reflection. Total internal reflection with the same angle. With the same angle, that is nothing but 60. Correct? So wherever it is touching, keep the protractor. Okay, protractor like this. So from the center, draw the normal. Now it is on the normal, almost. Okay, almost near to the normal, almost near to normal. So sometimes without knowing this angle also we can complete the angle, because we will get to know it is less than 42 degree, correct. It is less than 42 degree, but for a safer side we'll find it. Okay, this line is divided, we created one triangle. Where is that? This is the triangle. See, 30, this one. Okay, this angle, this triangle we required. Okay, so this is, if this is 30, we need to find this one and this one, correct. So from this picture, this complete normal, from the normal to this surface it is 90, some part is 60, so this will be 30, 30 and 30, 60. Okay, this angle will be 120, the complete angle will be 120, correct, the complete angle. See why it is 120? Because this is 30, this is 30, 60. The total angle of a triangle should be 180, 60, remaining should be 120, 120 plus 60, 180. Now it is correct, 120. But from the surface till the normal it is 90. From the surface till the normal it is just 90. The complete angle till here, okay, this line is 120. So 90 minus 120, it will be 30 degree. So this angle is 30 degree. If the angle of incidence, okay, is less than the critical angle, what happens? It undergoes refraction. But here whether it goes away from the normal or towards the normal is important. Whenever light is coming from denser, this is denser, rarer, denser to rarer, the speed increases. If the speed increases, it goes away from the normal. Okay, almost not exactly like that. See, because of this one, this ray, it will go here. So some changes. Okay, some changes. This will be the emergent ray. That's it. So whatever the question they give, okay, first try to, whenever you get confusion, just go back, rewind it and watch it. You will definitely understand whatever the procedure we have learnt in previous questions and all, the same procedure here. It is little, we are getting more angles. Okay, here analysis is very much important. The total angle is 120. From the normal it is just 90, so 90 minus 120 will be 30. 30 less than critical angle, so it goes, it undergoes refraction. Our last question. The diagram given below shows a light source P embedded in a rectangular glass slab ABCD. Critical angle is 42. Complete the path of PQ till it emerges out of the block. Write angles wherever it is necessary. Okay, listen. So this kind of questions we have solved one more That is question number 7. Question number 7 is almost like this only, but there it was curved glass, here it is a rectangular glass. Everything remains same. So we'll follow the procedure. Now listen, the ray is inside the glass wrap. Okay, now see, wherever it touches, keep the protractor, draw the normal. Okay, keep the protractor center, you draw the normal. Now which angle we required? This is not the incident angle. This is just given as a distractor or a reference angle. So using this one we have to find, see, always this is the incident ray, we require this angle. This is the angle of incidence. If you take this as angle of incidence, so we know critical angle is 42 degree. This is also 42 degree. Then the refraction will be on the surface. Completely wrong. That's why, so we have to understand which is the angle of incidence, which is the reference angle. This is the reference angle to find the angle of incidence. So why do we draw normal? This is 90, this is 90, this will also be 90, this will also be 90. From this surface to normal it is 90, some part is 42, this will be 48. Now angle of incidence is 48 degree more than the critical angle. What happens? It undergoes reflection at the same angle, 48 degree. Now whenever these ray go, it will definitely create a triangle. See, this ray has created a triangle. Find the angles of a triangle, we'll get the angle. First, see here, whenever it is touching, keep the protractor. We can keep it this side or this side. At the center, you draw the normal. This angle we want. How do we find this angle? Using the triangle, angles of the triangle. If this is 48, this will be 42, correct? Because this is come from here to here till this surface, it is 90. Some part is 48, other part will be 42, and this we can aramse say this is 90 degree because two straight lines, correct? Perpendicular 90 degree. If this is 42, 90, this will be 48. Why 48? Because this is a triangle. In a triangle, total angle will be 180 degree. 90 plus 42, okay, 132. Remaining will be 48. So now we know this is a normal. This will be 90. This will be 90. From this normal to this surface, it is 90. From this normal to this surface, okay, this surface is 90. One part is 48. This part will be 42 degree. So if the angle of incidence is equal to the critical angle of this glass is 42. So if both are same, it undergoes refraction on the surface. So exactly on the surface it will go. This is the diagram they're looking for. Now we have completed all the theory questions, correct? So many students will have confusion while drawing these kind of diagrams in the board exam. See, if you know the procedure, 3 to 4 marks within 1 minute you can get. Drawing with the procedure, or say, if you know which angle you have to take, where you have to draw the normal, and finding the triangle, angles of a triangle. If you find the angles of a triangle, other angle we can say find it. If you know all these procedures, you can solve any question related to diagram in the board exams also. So now we have completed all those things. There is no numericals. First, watch the concept. Whenever you're starting any new chapter, watch the concept video. Okay, watch the concept video, then you go for the theory solution. If you have numericals, we can go for numericals later. Now for this chapter we don't have any numericals, so after the concept, this is the theory solutions. So I believe you have understood everything. If you find any difficulty, if you can find any confusion, go back and rewatch it. You will definitely understand. Thank you.